Hi, I'm Mark Pivac, CEO at FBR. I'm standing in front of Mantis in its final form. The last time you would have seen it, it was set up in a test rig demonstration phase, and we've now got the twin wire high deposition welding equipment installed, both the torch and the power supplies. We've run all the wiring in the correct form and installed all of the precision bearing reducers, and Mantis is now being commissioned and calibrated, set up ready for high deposition welding, and we'll be starting our welding trials and demonstrations very soon. So once again, you can see how high Mantis can reach up. This is really important in shipyards and for large fabrication work, so that we can work at heights which would normally require scaffolding or could be quite dangerous for humans to work at those heights. Of course, Mantis can reach even higher than this. So this is a standard 15 kilo industrial MIG wire welding spool that you would use on a manual machine. We can also fit these onto Mantis, but because of the high deposition rate, these are the 250 kilo drum packs of wire which would normally be used on a robot like Mantis. In the MIG welding process, this MIG wire is continuously fed into the weld pool. The electric current actually passes through the wire and forms an arc between the end of the wire and the workpiece, and that's what melts the wire as it's continually fed into the job. The welding process which we use here actually has two of these wires to be fed into the melt pool, and each wire is powered by an individual power source, and that power is pulsed individually to each wire, so they're melted in turn, and this allows a much higher deposition welding rate than what can be achieved by just using a single wire. Here we have the twin wire welding torch. You can see the two welding wires coming out here. I can remove this gas shroud, and you can see there's two contact tips and two welding wires here. Here we have Mantis doing a simulated weld. Of course, if the arc was on, I'd be in full protective equipment, so that's one of the reasons we don't have the arc on here. Right now we're moving at 1500 millimeters a minute, which is quite fast for welding. There's a lot of reasons for Mantis. Globally, it's estimated there's about 200 to 350 major shipyards, up to 10,000 heavy structural steel fabricators, another 400 to 500 mining equipment manufacturers, 5,000 to 8,000 pressure vessel manufacturers, 1,500 to 3,000 bridge and infrastructure fabricators. Now, Mantis could be used in all of those. A lot of those yards are massive operations. It's not unusual for a shipyard to employ 20,000 or even 80,000 people, and a large proportion of those are welders. There's massive shortages of welders globally. Even in many Asian countries, they're short of welders. So this really is a growth industry. What we've seen is that automation has already made its way into very high production environments like automotive and white goods manufacture. And Mantis really is the first very large scale robot which has been designed from the ground up to service the heavy fabrication, shipbuilding, defence and mining industries. So our mid-range marketing analysis has looked at about 18,000 facilities globally that we think could use Mantis. Some of those facilities might only have one or two Mantises. Many would have hundreds or perhaps even thousands. So if we looked at the total deployable units at perhaps 100% penetration, we're probably looking in the 30,000 or more Mantis units. Perhaps we could look at a realistic penetration over the next 10 to 15 years of maybe 20%, with an approximate sale price of about 700,000 US dollars. And of course, that could be higher or lower depending on specifications and the installations and that sort of thing. That's sort of looking at a total addressable market of about 5 billion US dollars. And if we annualize that, we're looking at, at least $400 million a year in terms of revenue.